Remember that log with base a of x is a function that's the inverse of the exponential function a to the x. If you're not clear what that means, you should review the video on logarithms. Also remember that the number e is approximately 2.7 and it's a mathematical constant. Especially in calculus, it's very important. F of x equals e to the x is our favorite exponential function. And if you're not familiar with exponential functions, go watch the video on exponential functions. Log base e is our favorite logarithmic function, and it's so important that it gets its own name and shorthand notation. Log base e of x, we're going to denote ln of x. So we're replacing the symbol log base e with ln. We're saving ourselves 2 characters. This ln comes from the phrase natural logarithm. What that means is that e is the natural choice for a base in logarithms. So this number e, about 2.7. So if you see ln of 5, just know that means log with base e of 5. And if you remember how logs work, that's like saying, what exponent of e gives me 5? And now that's not going to be a nice whole number, it's going to be a decimal number. If you come across ln 5 as part of an answer, you can leave it as ln 5 unless you're asked for a decimal approximation. Also note that ln by itself like this is actually meaningless, just like an empty square root sign. Ln is a function you need to take the ln of something. There needs to be a number in here. And that number is the independent variable. Here's the graph of ln x right here. It looks like a typical logarithmic graph in that it gets really, really close to the line y equals 0, but it doesn't touch. The domain of ln x, like all logarithmic functions, is positive numbers, positive values of x. Like all inverse pairs, e to the x and ln x are mirror images in this line y equals x. That's because they're inverses. Whereas you have a point 1, 0 down here, then you have the point 0, 1 up here. There's a button on your calculator for calculating ln. It's right here. So again, if you needed to know the decimal value of ln 5, that's how you would figure that out. There's a useful property of logs for any log base where if you have the log of something to a power, then that power, the exponent, can come down in front and be multiplied. This is true when you have ln, because that's just log base e. So ln of x to the 5th, say, you could rewrite that as 5 ln x, and sometimes that would be helpful. So what are you expected to know? To summarize, you need to know what's meant by ln, in other words, log base e. You need to know that power exponent rule I was just telling you about. So if you have ln of something to a power, you can take the power down in front. You need to know that ln e and ln 1 simplify. You don't want to leave ln e in your answer. Let's figure out what ln e is. Ln e is log base e of e. So that's what exponent of e equals e, and the answer is 1. So ln e equals 1. What is ln 1? Ln 1 is log base e of 1. What exponent of e gives you 1? What exponent of anything gives you 1? 0. So ln 1 is 0. So know those 2 simplifications. Don't leave ln 1 in your answer. It's just 0. You need to know the domain, you need to know what the graph looks like, and you need to know how to evaluate ln on your calculator.